Welcome back to our series on building a virtual console. As you can see, we made quite a lot of progress, and this is showing three different things going on, one of which is new, and the rest I've combined with this demo. So I'm controlling a sprite, which is the smiley face with a gamepad. The things it's jumping into and getting blocked by are from a tile map, so that's coming from the tile map system. And then the starfield in the background that's being animated is the linear-framebuffer. So all that stuff's getting sort of composited together by our hardware to our emulated hardware to create this this demo. And yeah, I have got my gamepad in my hand. I'm not faking it. So that's what I've been up to. It didn't take too long. If you saw the last video, we got the sprite system working. It was not a big leap from there to the tile map system. I've created a tile map editor, which we'll take a look at too. And then, I spent some time creating some assembler to make it all work. So yeah, that was, it's kind of cool, I think. I think. I'm really pleased. I'm really happy with where that's got to. So let's dive into it a little bit in terms of how did I get here. So in the console, one of the things I've added is a map editor. Sorry, Matthew, you all right, mate? Sorry. My friend is dreaming. Okay, so I've got a map editor. Interesting. I think I might have broken something. Because I'm on the wrong. I'm on the wrong P bin. Let me get to the right P bin. No, this one. What am I looking for? Yeah, that. Sorry, I was on the wrong sprite set. Not P bin. Palette. I've got one palette in there. I've got one palette set. So that just reminds me, I need to save that in the config so that it opens when we open the level editor. But I've got a level editor. In theory, the tile map will scroll. I've just started because I wanted to kind of get the compositing together, and just a general demo going. I've not done scroll yet. In theory, it will scroll. You can do bigger levels. You can zoom things. Actually, let me open up one of my trash levels because I don't want to break this one. This is part of the game, but I've uploaded this very simple game. But that's the one we're looking at in the tile editor with some sprites that I drew. By drew, I mean I found a free set and I replicated them in the console because I am no artist. If we go to another level, you can create levels of arbitrary sizes up to the sort of 64k limit that we've got. 64k, 32k limit that we've got for sprites to fit in a system, and you can pick sprites and you can draw them with a pen. And basically, all the same features that are in the editor you can use in here. All the same editor features are in here. You can also pick tiles and modify their attributes. So one of the things that's interesting about the tile map system is each tile can have a different palette. So you can have I've obviously drawn them with a palette, but I could, for example, pick this tile and then say use a different palette. Now you can only use the first four palettes in a palette block for that. It fits in a sort of attribute block that I've got, but you can swap the palettes around. So we could have, for example, water in here too. It does mean the tile map is not affected by the scanline palette indexes. That just affects the sprites and the linear frame buffer, but it allows for quite a lot of versatility in creating levels. So you can create levels, edit, etc. So that's one thing I did. Actually, I've not tried doing things like flip vertical. I ought to give those a go. I've not tested that yet. Fine. That's the editor. When you do a new level, I'll just shut it down and I won't save my changes. I'll make sure I don't save my changes there. When you create a level, you can essentially give it this arbitrary size. And essentially, you've got up to 16,380 tiles max you can do. I've kind of put some handy screen-based sizes in there, or you can just put an arbitrary number in. So that's the tile editor. And that was, obviously I needed to split it out levels, so that was a block of work that unlocked everything else. I've made some slight changes to the palette editor. You can now rearrange the palettes by dragging them up and down. which is quite handy when you've done a bunch of palette work and you realise you want the palette in the first four for the palette system. And in the cartridge system, I've just realised this isn't very zoomed in. Let me zoom it in. You'll probably be able to see enough. Let me just zoom it in a bit. However, in the palette system, not a palette system, the cartridge system rather, I've added the ability to add the palettes and the tile maps into the cartridge. Cool. Okay, so that's kind of how it all came together. Obviously, I've still got the editor. As you can see, there is quite a lot of assembly for that, even though we're leaning on the sprite system. And so we could go into WebStorm. Let me just whack up the zoom on it. A second. If we go into WebStorm, if you want to see these things, make it fit a bit better for people. Okay, if you want to see these things, I basically started to create some projects under here. So I've got simple sprites from the last episode, and this is the platformer. So you can get everything out, open that up in the IDE, and start tinkering with it. I'm going to start pulling out some of the useful assembly into kind of runtime assembly that you can ship with your game, so you don't have to write all the collision code from scratch, and etc. etc. And hopefully we can get some nice starter packs for different kinds of game. That'd be cool. We've moved a long way from from where we were just a few weeks ago, so it's pretty cool, really. But how did I get here? So as I say, I took the same process really that I took with the sprite system in the last episode. So I had a tile map spec, which was fine. I'd written this some time ago. Actually, I was still pretty happy with it when I reviewed it. The thing I did do, I realised we'd got quite a lot of specs and we were all getting quite interdependent. So one of the things I did do was I asked Claude Code to look at particularly these specs in hardware, but I also looked at the others too, but focused initially on hardware. I asked it to look and make sure that they were consistent, particularly in their use of addresses, etc. And it did reveal a couple of places where things had got a little bit out of sync. So I fixed that. It wasn't too bad, just a couple of places I got out of sync just from writing these at different points in time. But yeah, essentially the tile map is a set of, let me find the bit that's of most interest. It's a set of rows, and in here there should be tile map attributes. There's a bunch of attributes, so you drag the tiles on and they're laid out row-wise, fine. 2 bytes per tile. 1 byte is the index into the sprite file, the graphic file, and the other is the attributes of it. Is it behind or in front of a sprite? Is it horizontal? Is it flipped horizontally? Flipped vertically? Which palette are you using? So this is the thing I was on about, where you can have tiles next to each other which actually use different palettes. So we could draw out quite nice grass because we've got quite a nice 256 colour palette. We could pick 16 colours for grass. We could then have 16 colours for water and put those next to each other. I've not used bit 2, as you can see, and in theory, I'm not sure I'll ever do this, but some brave soul may. You can actually use up to you can use 2 graphic banks for tiles. So you could have up to 512 different tiles, basically. That'd be quite a lot of different tiles for a level on an 8-bit system, but in theory you can do that. Yeah, so I drafted out this spec basically. Again, I took the same approach. I said, because this was quite complex, I was like, give me an implementation spec, please, which was fine. And I asked it to take the same approach, but I'd taken a sprite engine, which was to pull the sort of hardware away from the renderer so that it was a really clean split in that space. Yeah, and it created a spec for doing that. At this point, I'm finding Claude has a lot to go on. Like I've given it an awful lot of specifications over time, and I'm finding that I can assemble new bits of work quite quickly from the existing specs. The console is one of those systems that is dense. It's interlocking and the things all go together, so you get that kind of I never know the phrase for it, but that kind of compounding value from the specs being well written and organised. As they come together, it becomes easier to do new things. Just kind of, it's dense. The complexity is dense. There's a lot of density in it, which makes for some difficult reasoning at times, but at the same time means you can get a lot done with a little. So that's how I put it together. And then in the source, it's the same. It's exactly the same. So in the console, source, there's a tile map engine. So just the same as the sprite engine, same organisation, very similar code. In fact, to be honest, it's pulling the tiles out of a bank memory. It's not that dissimilar. The renderer is not dissimilar either. Go to the renderer, client source, application, console integration rather, tile map renderer. It's not dissimilar, and if you look in the, it's not dissimilar. It's building buffers and things again. And then if we go into WebGPU rendering and we go into our shader, we'll find it's not dissimilar again. We've basically expanded out this to include the tile map. So it's building up frame buffers and passing them in really. I say it's not that dissimilar to what we've done before. I just realised I have not tested the priority of the tile maps yet. So I need to do that. I need to test the flips. Make sure they actually work in the actual console. It was surprisingly sort of unpainful getting to this point. It was actually I would say very straightforward. The main issue I had is I realised that if you recall, some time ago we'd moved from little endian to big endian, and I'd left some specs that were not clear about the endianness. And when I generated the assembly, I started sort of using the assistant to write some assembly. I wrote a bit, it wrote a bit, and one of the bits it wrote was hooking up the VBlank, and it had done it the wrong way around, and we ended up sort of trying to debug quite complicated. Why is this memory corrupt? And I got Claude code on it, and it went down this big sort of can of worms with the assembler and the CPU, which I was pretty confident were working because we've got quite a lot of tests around them, and there's nothing really changed there. And it turned out just to be really subtle in the addresses. It had used little endian rather than big endian, but the naming was the wrong way around to the way it was being used, which just made it really unclear to read and unobvious. And I think that was a result of the specs being unclear. So it just shows the clarity of the specs and the consistency of the specs are really what lead you to, success or failure with this stuff. It really is a big factor. But I'm really pleased with that. I think that's really cool. And we can still, I don't know where I am with assembly code, but we can still do our breakpoints. It all works. All that stuff still works. We can still use our debugger. It's in a pretty good spot. One thing I do want to do, I haven't done this yet, is actually it's worth talking about this. Let me just run the game again. If I run it, it makes more sense. So things are in different banks, and one thing that's happening here, if you were to go into the assembler, is although you can detect in the hardware if a sprite has collided with the tile map, that happens after rendering, which means you're already going to be like a pixel or two into the overlap when it displays, which is pretty grim. So that's really useful for like explosions and shooters and things like that. It's not that useful for a platformer. So I wrote some code to detect collisions of a sprite against the tile map, which is done in the CPU. It's done in software. But the tile map is actually in a different bank to the frame buffer, and I'm also updating the frame buffer for the stars. So to read from the tile map, we have to use a bank switch, which is done by, if you look in the spec, if you look at the start of a memory map spec. So much in my brain today. If you look at the start of the hardware registers, the first one is a bank register. Bank, which I think we covered this in the last episode. Bank 0 is a frame buffer, and actually in in the way I've assembled the cartridge, I think bank 20 is the level. So that means when I'm working on the stars, I switch in the frame buffer bank and I write to the frame buffer. And when I'm done with that, I switch to the tile map bank and I look for collisions of the tile map. So we've got this 64K of memory, and we're swapping it, the upper half of it, in and out to do different things, which lets us access more than 64K, including, I mean, the tile map is essentially in ROM. You can't write to the cartridge. Well, actually, it dawns on me, I've not explicitly forbidden that, so we could write to this cartridge, but that'll be turned off. The cartridge is ROM. At the moment, it's not really. I mean, it's not really ROM anyway, is it? It's running on my machine, but I want it to behave like ROM. But you could copy a tile map into memory and then modify it, which is the sort of thing that happened in some games. We could do that quite nicely. That's it. I mean, I think that's pretty cool. We've come a long way from a hex dump in the console to, now having essentially a console which we can write. It's not a game. We can't, there's no win condition on it, but we've got, interaction with a gamepad. We've got animated graphics. We've got tile maps, backgrounds. I will test for scrolling. That'll be the next video. We'll probably create a little. I might create. I'm not sure what slowdown. Occasionally I get slowdown, which is interesting. I'm not sure where it comes from. I mean, it might be coming from the console. It might be legitimate. There's quite a bit going on. It might be the render loop timing is going a bit squiffy. I probably need to look at that, do some measurements. In the next episode, I'll probably have got the scroll working. We can talk about the scroll. Probably the first game we create with this system is going to be a simple platformer. Perhaps do a horizontal shooter, which we'll use the sprite system predominantly, or a top-down shooter perhaps. We'll see. The world is our oyster. The world is our oyster. But we're starting to get a real console. Obviously I need to get audio in here as well. When it can go doing, doing, that'll make it again more gamey. But yeah, I hope that's interesting. It's really cool. Really fun to work on. Really fun to work on. Sort of has the benefit of being quite fun code, quite fun to work with the AI on, and rewarding. Takes me back to my youth as well, which feels a long time ago. I mean, if I had an IDE like this when I was a kid, it would have been amazing. I did not. Anyway, I hope that's interesting, and I'll see you in the next episode.